Welcome back to Battleship Systems. There's a fully immersive experience waiting for you when you visit a Battleship museum. Not only can you adventure through a World War II artifact, you will hear the same announcements and alarms that called sailors into action. Today we cover the system that allowed officers to address everyone on the ship instantly. Please check the errata page in the description. Battleships have transmitter stations that allow you to speak to virtually every compartment on the ship, including the weather deck. The system is collectively referred to as the 1MC. The system has to be loud enough to be heard over loud machinery, yet quiet enough not to alert the enemy. This video covers the general announcing system of the Battleship North Carolina. However, most battleships have very similar setups. The part of the general announcing system we're probably most familiar with are the reproducers. The North Carolina uses these Class L and S reproducers for low and standard outputs respectively. They work exactly the same as the speakers you're listening to now. The voice coil energizes and moves the cone diaphragm back and forth to replicate the announcer's voice. All loudspeakers have an internal transformer with different taps so you can set the volume level. But what about compartments that are too big or have really loud equipment? In these spaces you will find the Class H and M reproducers for the high and medium output levels respectively. They are not your typical cone speakers. These are horns. Horns are more rugged and efficient than direct radiation speakers. They are also water and explosion resistant. The heart of the horn loudspeaker is the diaphragm, which is really a compression driver. It's designed to compress a small amount of air at very high pressure into the throat of the horn. Then as the sound wave moves through the horn, it is allowed to expand. This results in a velocity increase which makes the horn speakers project sound further and sound louder. Originally, the North Carolina had at least 146 cone reproducers and 28 of the horn type. So what powers all these speakers? Well, you remember back to the episode we did on the power system of a battleship, you know that there's no shortage of available kilowatts on Navy battleships. The trick is to apply it to the speakers and vary it in such a way that creates sound. Take a steam whistle, for example. You can vary the rate of steam entering the whistle by adjusting the valve. In a way, you are amplifying your message with the steam and varying it with the valve. So what does an electricity valve look like? Think vacuum tubes. Now, I don't really want to make this an electronics channel, but there's something to be said about their engineering. So, when you heat a wire up, it melts. But when you heat it up in a vacuum, something interesting happens. The electrons in the wire pick up speed and shoot out of the wire. This process is called thermionic emission. Normally, the electrons will stay close to the wire, forming a space charge. This makes up the cathode part of the vacuum tube. They also have a plate known as an anode. Say we connect this plate to a load and then to another battery. If we connect the other end of this battery back to the cathode, something remarkable happens. The electrons are attracted to the positively charged plate, and so they drift through the tube and are collected by the anode. Electricity is now flowing invisibly through the tube. This type of tube is known as a diode. What's unique about the diode is that it only allows current to flow one way. If you give the cold anode a negative charge, there will be no thermionic emission. Diodes are useful in rectifying AC into DC and are used throughout the announcing system. Now let's stick a wire mesh electrode between the cathode and the anode. If we give this grid a slight negative charge, the electrons will just stay in their space charge. If we remove that slightly negative charge on the grid or give it a positive charge, the electrons will once again make their way to the anode. This type of tube is known as a triode and can vary the flow of very high voltages with small variations in the grid voltage. It's like a valve for electricity. Okay, so here's a simplified overview of how a tube amplifier works. You have your microphone, your amplifier stages, and your speakers. The amplifier takes the 115 volts alternating current from the chip and steps up the voltage using a transformer. It then converts this into DC by using a rectifier. Rectifiers use diode tubes as a one-way gate to stop the alternation. The high voltage DC is applied to a triode's cathode, and the anode is connected to our load. Since a microphone turns our voice into a small amount of electricity, if we connect this microphone to the grid of a triode, we can effectively amplify the microphone's power. Amplifying signals this way usually involves extremely high voltage, more than the reproducers can handle. If you remember back to the episode we did on transformers, with alternating current we can use a step-down transformer to decrease the volts and increase the amps. Since a sound signal is a form of alternating current, if we hook up an output transformer to our amplifier, we can drastically step down the voltage. The resulting circuit is known as a transformer-coupled amplifier. 1MC is just one circuit of a system known as the type MCG General Announcing System. The MCG encompasses the General Announcing, or 1MC, Engineers Announcing, or 2MC, and also includes the Damage Control Circuit. All of these circuits are critical to a ship's fighting ability. This is the amplifier rack for the MCG. It was located in the interior communications room on second platform. Inside are 2 voltage amplifiers and 2 power amplifiers. 1 voltage amplifier and 1 power amplifier pair make up a channel. So there is an A and a B channel. We'll get into why this is later, but it's important to note that the audio is first amplified in the voltage amplifier and then sent through a power amplifier. Let's focus on the voltage amplifier. On the top are the tubes for the rectifier and the amplification stages. The unit on the bottom is known as an audio compressor. It's used to even out the levels of audio from the microphone. When we speak, the consonants in our words contain less audio energy than the vowels, and it's hard to understand what somebody's saying if you can only hear the vowel of every word. Here's an example without compression. And here's that same announcement with compression.
Lights out in all berthing compartments. Maintain silence about the decks. The smoking lamp is out in all berthing compartments.
From here, the signal is sent to the power amplifier. It's similar to the voltage amplifier, except that the signal gets amplified to an even higher voltage. In fact, it employs such a high voltage it has to use mercury vapor rectifier tubes. Mercury atoms become excited when electrified, causing the tubes to emit a purple-blue ultraviolet light. So what's up with the 2 channels in the amplifier rack? Well, the Navy wanted a way to make announcements for everyone on the ship, but also a way for the engineering department to announce to their personnel only, and possibly at the same time. And since this is a battleship system, we need the ability to take one of the channels down for repair or testing without taking the 1MC out of commission. This switching takes place in the control rack, which sits next to the amplifier. The MCG Control Rack contains all the switches, meters, relays, resistors, and other equipment for the 1MC, 2MC, and damage control circuits. High voltage audio enters the cabinet and is fed to either an output coupling transformer for the 1MC or a resistor network for the 2MC. The 1MC, 2MC circuit is broken up into groups. That's officers, engineers, crew forward, crew amidship, and crew aft. You can cut out the groups that you don't want to announce to, but what happens when you pull speakers out of a load? This decreases the overall load and causes the other speakers to get louder. That's why power to any reproducer group that's not selected is sent to a dummy load resistor that takes the place of the loudspeaker load. Here is a diagram of the MCG in normal operation. The first half represents the components of the 1MC. You see the transmitters, amplifier, control rack, and reproducers. You can talk to any reproducer group from these control stations. However, on the 2MC side, these transmitters can only talk to the engineering group. However, if someone is simultaneously using the 1MC circuit and selects the engineering group, the 1MC transmitter takes priority. You may have noticed this thing called a signal generator. This creates the two audio frequency signals for the 1MC. There's the general alarm to let everyone know action is imminent and to get to their assigned stations. Then there's the chemical attack, which is used when there's a chemical warfare agent in the air and everyone needs to close vents and don gas masks. You probably heard the general alarm sound before when watching war movies. It sounds like a bell being struck. Well, it wasn't always that way. Originally, the USS North Carolina's general alarm was a 600 cycle tone sounding on and off 90 times a minute.
Man your battle station!
This sound was kept playing on all MGC circuits for 15 seconds by a timer. The chemical attack was just a constant 600 cycle tone. Pretty boring. So why do we hear a bell sound in the movies? Well, I found some information on this, and believe me, it's not a recording of a bell playing over and over. There's an interesting addendum in one of the instruction manuals. Not only does it imply the signal was changed to 1000 Hz, it says the original signal generators have been replaced with a new one, changing the general alarm from an interrupted signal to a simulated bell tone signal. Now, as far as when this change was implemented, I don't know. So how do you generate a bell sound? It's actually quite simple if you understand how oscillator amplifiers work. It starts with a motor that momentarily energizes a circuit with every revolution. This is known as an interrupter, and it sends power to two oscillator circuits 90 times a minute. The oscillator circuits are comprised of a triode connected to a resistance-capacitance network. That's a network of resistors and capacitors designed to keep the grid voltage 180 degrees out of phase from the plate voltage, resulting in oscillating power. One oscillator circuit generates a signal of 1500 Hz, while the other generates a 1000 Hz signal. When these two frequencies are combined on a single speaker, it sets up what is known as a beat frequency. These two frequencies interfere with each other, making it sound like the tone is changing. Finally, after the interrupter cuts off power to the oscillators, a capacitor discharges a diminishing degree of power through the circuit. Simulating the ringing of a bell after being struck by a hammer. Okay, so that takes care of the signal generator, the control rack, and the reproducers. But we haven't talked about the transmitter stations yet. These are big boxes mounted on the bulkheads with hinged covers. A fixed microphone extends from the control panel. Switches allow you to select which groups of reproducers you want the announcement to go to. When you hold down the press to talk lever, the 1MC busy light is lit and you are ready to announce. The engineer's transmitters in the log room and engine room are identical except that they only have a switch for the engineer's group. When using these transmitters, the 2MC busy light comes on to let everyone know the circuit's in use. You can also hook up a portable transmitter to these stations so you can make your announcements remotely. Captain Hanlon used this in 1945 to announce the end of the war from his cabin on the 04 level. By the way, I know at my school there will be certain students selected to read the morning announcements on the school's PA system. Did you ever make an announcement at school or at work? Did it make you feel cool or important? Let us know in the comment section below, and don't forget to like and subscribe. The damage control circuit allows you to announce on the damage control reproducers that are normally connected to the 1MC. Its amplifier and transmitter are located in the damage control station. The transmitter switches select individual repair stations as opposed to groups. When using this transmitter, the repair station reproducer is disconnected from the 1MC and placed on the damage control circuit. There is also the ability for the repair stations to talk back to DC Central by means of the talkback switch. When you press this switch and speak into the speaker, it will be broadcasted to the damage control station. The MCG is a critical system, a battleship system. That's why it's designed with doubled vacuum tubes connected in parallel, multiple signal generators, integrated test equipment, and is kept in an air-conditioned room. After all, a casualty to the MGC system would leave the ship without any way to call the crew into action. It should be noted that even as reliable as this equipment is, it's not necessarily something you want to or have the ability to use today. The amplifier rack is missing on the USS North Carolina, but like most museum ships, they still play sound on the loudspeakers for their visitors. Just don't confuse them with museum announcements. All of the battle announcing equipment on the Battleship North Carolina was made by RCA. Most of the battleships used RCA equipment. In fact, the battle announcing system on the North Carolina is exactly the same as the one used on the Alabama. The Iowas originally used Western Electric for their announcing systems. They were pretty much identical to the RCA equipment. You have an amplifier and control racks in the IC room, with the transmitters and reproducers mounted throughout the ship. That's not a hubcap in the boiler room. That's a Western Electric horn loudspeaker. It was used in the high noise environments just like the Class H and M reproducers for the RCA systems. After modernization, the Iowas had their original MGC systems replaced with modern Dynelec equipment. It served the same purpose, but the Iowas now have more transmitters, more groups, more reproducers.
Sweepers, man your brooms. Make a clean sweep down for an sweep down low decks, ladders, and passageways. Now sweep.
And a new fancy collision alarm. And a flight crash alarm. Unfortunately, I can't find a manual for the system, so I can't provide any more information than that. In lieu of donations to me, please consider donating to a battleship museum like the Battleship Alabama. There's a link in the description that'll bring you to the USS Alabama Battleship Foundation website where you can donate to the nonprofit organization. Don't forget to put Battleship Alabama in the comments of your donation so your money will go to the ship. Thanks for watching.